This is actually one of my very favorite lessons of the year. It takes something that you already know and we approach it in a completely different way. And this is one of those things that will help us solve problems in your head, which I always like to do. The first thing that we need to learn to do, though, is exactly what a determinant is. And this is something that once you know, there will be a problem like this on the ACT, and as long as you know how to approach it, it is like that quick and that easy to get the right answer. So this is one of those. A determinant, usually represented with straight lines on either side. It's not absolute value. And then these guys in here are elements, and your determinant can get bigger and bigger and bigger and bigger. These are used in linear programming. This is one way that they do computer programming is with determinants, but we're not going to get anything that fancy in algebra. Now, you can see how this works. This is how we evaluate it. Depending on how you write your x's, it makes this easy. I write my x in this direction, this way, and then this way. So it is AD minus BC. That's how it works. So this way first, this way second. And once you know that secret, you have to pay attention to your signs because of this minus in the middle. Translate that formula over here. I've got 3 take away a negative 10, which makes this what? Not a trick question, folks. 3 plus 10 is 13. All right, let's do the next one. This way is 2 times 5 is 10. Take away, second direction is 12, which makes this a value of negative 2. I gave you a couple of examples, but grab your phones. Tell me what determinants are used for. Just shout something out. Let's list a couple of things. Google it. Yell it so I can hear you.
Solving linear equations.
Solving linear equations.
Capturing how linear transformation changes area or volume.
Area, volume, translations. Anybody want to add anything else? You two okay? All right. Seem to be having a story that maybe I needed to hear because it didn't stop. Anybody want to add anything else? Hannah, you find anything else on there? We are going to save, holler if you hear it, we're going to save 3x3s for tomorrow because they're a little bigger. And we're going to use 2x2s with Cramer's rule to solve a system of equations. This is brand new, so it's kind of a gee whiz kind of thing, but this is my preferred way. I would rather use Cramer's rule than solving a system of equations by graphing or substitution or elimination. This is my favorite way. Like I said, depending on the numbers, I can do this in my head. Did I miss anybody that time? All right. Did any of you ever watch Seinfeld? Any of the reruns? All right. I can't ever, but I always think of him and associate it with this, Cramer's rule. We cannot do Cramer's rule without knowing how to do determinants, and that's why we just took a second to do that. C is the coefficient matrix. And I hope you guys are wise in the ways of knowing coefficients are the numbers in front of our variables. For this to work, you want to have your x's, your y's, your equals, and your constants. You want it in standard form for this to work. So to find the value of our coefficient matrix, I take this and I put them in the exact order I see them with the signs they have. And then evaluate that determinant. How do we do that? 20 minus a negative 18. You all right if I just change that minus a negative to a positive? And what does that equal? 38. Now, there is a nifty, fancy formula that you can find and look up for Cramer's rule. However, remembering the pattern and how it works is so much friendlier than following their formula. So if I want to solve for x, this is what I do. It says replace the x values with constants. So I had this coefficient matrix up here, right? And that stemmed from these numbers. Here are my x numbers, and what does it say to replace them with? The constants. These are the constants. So I'll write that right here in case we have some confusion. Constants, coefficients. So I'll replace that x column with 15 and negative 29. Y's stay the same. So that would be negative 6 and 4. And that says over the value of C. C was our coefficient matrix. And what did we get? 38. All right, let's evaluate this determinant. 15 times 4 is what? 60 minus, somebody do 29 times 6 for me. What do we get? 175? 174? So 60 minus a positive 174, that's over 38. That would be negative 114 over 38, which reduces to what? How many 38s are in 114? 3. So negative 3. Now, you can totally take this negative 3 and plug it back into one of your equations to solve for y. But because we're new on Cramer's rule, I just want to show you how we would solve for y using Cramer's rule. So it says replace the y values with constants. So x's stay the same. X's stay the same. So our x values were 5 and 3. My y's are now the constants, 15 and negative 29. 5 times 29, help me out.
Negative 1.
Negative 145 minus this way, 45 over C. What was our value of C? 38. Negative 190 over 38 is what? You texted in my class, Mr. Beezer.
No, I'm doing the calculator.
Good job, thank you. Negative 5? So my x value was negative 3. my y value is -5. Let me put up your homework and let's do one more together so it feels a little friendlier. That paper should probably have another example on it. I think your homework is open. Let's find out. Oh my goodness, 1,000 clicks later. The first handful of problems on this assignment are just find the determinant. But I would like to do one more problem together. Okay, we're not going to fill all that in. We're just going to solve the problem. Okay, what is my coefficient matrix? Remember what the coefficient matrix means? All the numbers in front of my variables, right? And I should double check. Are they in the right order? Have we got it in standard form? Yeah. So this is a 6, 9, -1, and -7. So that's a -42 minus a -9. What's -42 plus 9? You guys want me to be the calculator all the time? Shout it out. All right. So there's my C. If I want to solve for x, what do I do with the x column? What do I replace it with? The constants. 7, 1, the y's stay the same. All right, so that gives me -49 minus 9 over -33. Did I mess something up? That looks like a horrible number. Did I mess something up somewhere?
It's 1.75, but it's like repeating.
Yeah, because that's going to give me what? -58
Yeah.
over -33? Whew. You know what? I think I remember this section does have ugly answers, by the way. I think that's a real thing here. Okay, there is my x. Just like that. How do I find my y's? I'm still divided by -33. Help me set that one up. X's are 6, -1. What goes where the y's are? 7 and 1. So that is 6 minus a -7 over -33. -13/33. And you think you did something wrong, but it's okay. Was it a little easier to see the pattern, the second problem? Would you like to see another one, or are you ready to jump in?
One more.
One more? If you're ready to jump in, don't listen to me. You can just start your homework. All right, first thing I need is my coefficient matrix. We'll see if I can write it over here if I'll have enough room. Let's see. 7, 9, 4, -6. That's going to give me -42 minus 36 is -78. Okay, if I want to solve for x, I know I'm going to be dividing by that, -78. If I'm solving for x, I replace the x's with the constants. 8, 7, and the y's stay the same. Negative 48 minus 28 divided by negative 78. What is that? Negative 78, negative 76? Reduce that for me. Anyone? Got it for me, Hannah? Type it in. 38 over 39, I believe. Okay, and if I want to do my y's, I'm still going to divide by that coefficient matrix. If I want to solve for y's, I replace the y's with the constants. And the x's stay the same. 49 minus 72 over negative 78, negative 22, negative 23. Goodness, those are horrible numbers. My y value is 23 over 78. Better that time? Hey, if you get stuck, just ask me for help. Let me hit stop and I'll be right there.
I need to plug in my computer.
Oh, go right ahead.